Data does not become decision-making without intelligence in the middle. And that's where really Azure and IA put themselves together.
The extra convenience of having pause and resume and the easy scale up, scale down, that right there is just a pretty big chunk of savings.
Azure's better than AWS because they've thought this through.
What amazes me is how little hardware that we need, and we have literally saved millions and millions of dollars.
Data is where it's at. It's the lifeblood of every company that's out there.
The benefits we saw from the Azure migration was almost immediate. We were able to validate 28,000 invoices in less than 2 hours, which would normally take about 2 days.
The analytics engine that's been built on the Azure cloud allows us to collect and analyze the data needed to deliver the insights our customers require to stay competitive.
I get to use all the data, not just a subsample of it. It's increased our productivity by 50%. Azure Databricks is the best way to do Spark-based analytics, period.
We're using Cosmos DB because it allows us to distribute the data models to be near the services wherever in the world they're deployed, and Azure has delivered as a rock-solid platform.
One of the first tests of our new Azure implementation came with some breaking news. SpaceX just took off, and Azure just scaled right up with it.
All right. Does the mic work? Okay, this is interesting. Are you guys excited? Woo! I'm not hearing it, man. Should you get some more coffee? You guys excited? Woo! All right. So, welcome everyone. My name is Rohan Kumar, and I'm the Corporate Vice President of Microsoft's Data Platform Business. My team is called Azure Data, and thank you so much for joining me here today. You know, as you saw in the video, we're really excited about the value our customers are getting from the Microsoft's data platform investments. You're seeing how they're able to leverage a lot of their existing investments and get a lot more value out of it and build new digital experiences on the Microsoft data platform. It's truly exciting. Okay. Now, it's amazing to actually see the total amount of innovation that we've delivered in the last 12 months. From Build 2017 onwards. You know, when I was a developer, well, yeah, it is pretty impressive to see that list. You know, there's lots of hard work went into each of the line items you see on the slide. You know, when I was a developer, it was impossible to imagine this pace of innovation. You know, I actually wish I had only a fraction of all the services, capabilities, and features that exist on the data platform today to make my life simple. You know, and our commitment to you is we're going to continue to invest very, very heavily in the Microsoft data platform to meet you, the developer community, where you are. And we are going to invest to make sure that our data platform is future-proof to meet your needs of today and tomorrow. It's actually pretty exciting and humbling to see the rate of adoption of our data services and the momentum that's being built around it. Let me share you some data to make my point. SQL Server 2017 has already seen 5.6 million downloads. You know, that's almost 10x greater than what we saw with SQL Server 2016. It's amazing. It's the fastest adopted release of SQL Server ever. You know, Azure SQL Database is the fastest growing hybrid data service that we have in Azure. We have 4.5 million active databases and growing at a very, very fast clip. Azure SQL Data Warehouse, our flagship Elastic Cloud Data Warehouse, supports more than 3 million concurrent queries per hour worldwide. Now, if you think a lot of those queries actually run for tens and tens of hours, that's actually a pretty impressive feat. You know, Power BI supports more than 7 million queries per hour across all their worldwide footprint. And finally, Azure Cosmos DB, the fastest growing data service that we have in Azure, supports more than 100+ trillion transactions per day. That's not a typo. That's 100+ trillion transactions per day. It's amazing. You know, and one of the reasons we are seeing this amazing momentum is because of the adoption of our products and services by developers like you. So thank you. You know, you're changing the world one algorithm at a time, and we are glad to be a part of it with you. You know, now all of us know that the true value of data, of an application, really is dependent on the volume and the quality of data that supports it. You know, the good news for us is that the volume of data is exponentially growing, and so we have an amazing opportunity to derive insights from it. It's not really about data only, though. It is also important to have highly sophisticated and highly scalable cloud services that give you elastic power of compute to almost grow infinitely when you need it, and also to support AI for smart analytics. Taken together, data, cloud, and AI are accelerating the pace of innovation, much like the internet did more than 20 years ago. Now, some of you may remember the advent of the commercial internet. Nobody could have predicted the impact it has had on the society and how it's shaped our everyday lives. We at Microsoft very sincerely believe that we are at a similar moment in application development today. Data, cloud, and AI taken together has the power to transform our world. We are only limited by our imagination, our creativity, and our ability to tame this huge volume and explosion of data by building disruptive applications around it. One such example is eSmart Systems. They've built an amazing AI-driven solution to essentially leverage drones to actually figure out issues that impact their power grid systems. Before they had the solution based on AI, it was a very manual process. Something would break down, then one of their field engineers would have to go do a manual inspection and figure this out. And some of these areas where they had these grids were in very remote and dangerous locations. Now with the solution that they have, they're able to do all of this remotely by flying drones all over their power grids and leveraging the power of machine learning backed by image recognition, right? So this whole solution has not only made it very, very safe for their field engineers, it's also significantly improved the uptime of their power grid. Because they're able to, based on machine learning and AI, they're able to predict well before the power grid or any portion of their power grid goes bad, and they're able to actually send their field engineers and repair it before the system goes down, right? So the uptime goes up, it's much safer for their field workers, and the efficiency and productivity of their field engineers has significantly improved, right? Now, this is a fantastic example of a solution that leverages the power of the intelligent edge and the intelligent cloud from the Microsoft Data Platform put together, right? It's a truly, truly disruptive application. Another thing that we foundationally believe is that the more integrated these data experiences around the intelligent cloud and the intelligent are with each other, the applications and the solutions that are built around it, the faster it is for them to actually get the power or the value of the data. The faster it is for you to innovate. The faster it is for you to create disruptive and rich and immersive experiences for your customers, and the faster it is for you to discover new worlds. At Microsoft, me and my team, we aspire to create a data platform that makes this possible for you. We're going to work to deeply integrate all our data services in a way that enables open and hybrid application deployments. It enables you as a developer to build intelligence right inside your application by leveraging the power of AI close to your data. By a show of hands, how many of you, either in your own organizations or in your customers' organizations, believe that all the on-premise investments that you have, you can shut them down and move to the public cloud tomorrow? Like a few. Like, how many of you believe that you'll never ever move to the public cloud? A couple. How many of you believe that your on-prem investments will continue to make sense, you want value out of them, and then over a period of time as your business needs arise, you might move some of your data to the cloud for things like analytics and such? Just look around, majority of the room. This is exactly why hybrid is a key principle of our product strategy. In everything that we do, one of the first questions we ask as we go through any sort of design review is whether, if a feature is getting built, whether the developers have to worry about where this application gets deployed, and the answer has to be no. The other piece is around intelligence, right? More and more as the data volumes grow, like I said, it's really important to have a data platform that supports the capability of leveraging the intelligence where your data lives. And that's something that we are investing in. So with that introduction, let's get going, on the hybrid piece of our pillar. The very first, okay, all right, so it finally works. SQL Server 2017 is, the latest release of our flagship on-premise server product that we released at Ignite last year. It runs on Linux, it runs on Docker, it runs on containers. And like I said, the adoption that we are seeing from this release has been just truly amazing. It's been well beyond what we had imagined. And if you essentially take a look at what really comprises this release, it sort of boils down to the pillars that you see on the slide. The first one is you can basically run it on any choice, any platform, any tool, whether it's Windows, Linux, you want to run on .NET, Java, Node, everything is supported. It has industry-leading performance across operational databases, data warehouses based on standard TPC benchmarks. It's the most secure system. This is, again, as measured by a third-party National Institutes of Standards and Technology of all the databases that exist. It's really lowest in terms of the vulnerabilities. It's the only database with AI sort of built in. What I mean by that is you don't really have to move your data, and all the policies, compliance, governance are maintained. You can run R, Python. We have support natively for graph queries, where you can model foreign key relationships in a very, very easy manner. And finally, support for end-to-end mobile BI at a fraction of the price that is supported by Oracle. All this with the support of in-memory databases across all our workloads, right? Because the price of memory chips are falling, and we're sort of betting huge on that. And it's a very, very consistent data platform from a hybrid standpoint. The best way to basically look at what we have done with SQL Server 2017 is through a demo. So let me invite Dean, who's the CTO of DV01 on stage, who's one of our customers of SQL Server 2017. Hey, Dean. Well, thank you so much for coming over to build. So can you share a little bit about DV01?
Yeah, sure. So DV01 works with some of the world's leading banks and financial institutions to centralize the data powering the $12 trillion mortgage, student, and auto loans market. We're doing our part to help prevent the next financial crisis by unifying the advanced quantitative analytics and reporting throughout the full life cycle of these loans. Trillions of dollars of these loans flow through our platform, so it needs to be fast, scalable, and performant. Initially, we built our platform off of Amazon Redshift and a generic OLTP database, but quickly realized that wasn't scalable as our platform grew and as our queries became more complex. At one point, we were spending over 70% of engineering time simply troubleshooting or optimizing database queries.
Cool. So how has SQL Server 2017 helped you?
Yeah, so SQL Server gave us the performance and scale needed to handle our rapid growth, cutting those complex analytical queries that were taking 30 seconds to just 1 to 2 seconds, and reducing database management overhead by over 90%. Our team was also really thrilled with both the Linux and Docker support released as part of the new SQL Server 2017, since they all come from an open source background, we're a startup, and they use Mac daily for their software development. And we've also been running SQL Server 2017 inside of Docker containers on Linux for the past year, and have been really happy with the performance, the stability, as well as the ease of deployment.
Cool. Has it impacted your CI/CD pipeline?
Yes, absolutely. So
all right, why don't we take a look? Thank you.
So I'm going to show how DV01 leverages the Docker support in SQL Server 2017 to streamline our development process from our devs' local workstations, that's typically Mac or Windows, to our CI pipeline in the cloud, and then to our production Linux VM instances hosted in Azure. So just making sure you can see the screen. So I'll just start with a simple git clone. And what this did is this pulled off all of our various code bases, Docker Compose configurations, which I'll show right now. And it's a pretty simple Docker Compose configuration. We have a Docker file for our Redis, our MS SQL instance off of Microsoft's Docker Hub, front-end, back-end, load balancers. And then all it takes is just running a Docker Compose up. And what this will do is this will spin up all of the services, build up these containers. There's a bunch of these containers being loaded right now. And it all comes up really fast. And the virtual networking between these containers are also all hooked up automatically so that these containers can all just talk to each other. A second, takes a moment to load. Now it's loaded, and I'm just going to log in. And this is all hitting a local SQL Server instance on my Mac with all the other services on there. And just like that, I have a fully running installation of our application on my local Mac development environment. Isn't that amazing? All right, so let's go one step further and make a database schema update. So I'm going to create a new SQL file and then just add a database migration to add an extra term of service column. I'm just going to save it and then commit it as part of VS Code. And then push it to our GitHub. So while that's happening, while it's pushing, the containerized SQL Server instances makes it really easy for us to test these type of code changes because it allows us to run a live SQL Server installation in the cloud with our continuous integration pipeline. And we can easily spin up, spin down these ephemeral SQL Server instances in seconds, ensuring that every single one of our tests starts out with a clean slate. And this should just show up any time now. There we go. So you can see CodeShip have picked up on my Git commit, and it's doing that whole same process that I just ran on my local MacBook, but now in the cloud. So it'll spin up all of these various services, connect them all together, and then run a full end-to-end integration test. So I'll also show you what a production run looks like. So deploying to production is just as easy as pushing to a production Git branch. And that's what a completed run looks like from a couple of days ago. And you'll see that I'll have tested all of our code, both unit tests and integration tests. And then it'll just push to our production, to our Docker Hub instance, where a webhook will just monitor pushes to Docker Hub and then automatically deploy the validated Docker builds to all of our production web servers. So hopefully I showed you how easy it is, where containerization support in SQL Server makes it really, really easy for us to set up a consistent application development environment across all operating systems, Windows, Linux, and Mac, and throughout the software development lifecycle, dev, test, and production, giving us full confidence to ship bug fixes or new features to our customers on a daily basis. Thanks for having me, Rohan.
Thank you, Dean. No, thanks. All right. That is really awesome to see the power of containerization with SQL Server, where the pace of innovation, again, like you saw in DB01, has significantly improved. All right. One of the things, as we're hearing from our customers, is they are, now that the public cloud is mature, they're really looking at migrating their existing applications. But a couple of very common requests that we get is, hey, how do you make that super easy by providing the tooling to ensure that the migration is seamless? And by the way, the actual investments that I as a customer need to do has to be close to zero, which effectively means if I'm picking an application and if I'm migrating it to Azure, then make it as seamless as possible it is for me. So these are some of the requirements that we're hearing constantly from our customers. So to that end, we've basically invested in two specific product investments. The first one is the database migration service. It essentially, with years of experience that we've had in migrating SQL Server applications to the newer versions, or even Oracle, Sybase, etc., a lot of that learning is going in to build that service. And finally, we have actually enhanced Azure SQL Database with a new deployment option called Managed Instance that supports nearly 100% compatibility with existing SQL servers going all the way back to SQL Server 2008. And when it comes to mission critical applications, we also know that it's never a one-way street where you just do the migration and then everything gets shut down at the source. It's really where you set up the migration pipeline, where you still have to accept changes on your source, because both the systems, the primary being on-prem and the secondary being in the cloud, is maintained for a while, and after going through extensive A/B testings, you finally do the cutoff. So we support that as well. It's reliable migration at scale, and for moving the data, you can use the replication feature that's always existed in SQL, or you can reuse the data sync service that we recently relaunched as a part of the public preview. And one of the biggest benefits with this is, even from the business side, with the Azure hybrid benefit for data, you can get up to 55% cost savings if you migrate your SQL Server applications to Azure. It's almost a no-brainer. If you're choosing to actually enhance your applications with richer experiences from the cloud, it's a no-brainer that Azure has to be your choice. One thing I'm really excited about is to announce the general availability of the database migration service. And this is, we've already migrated more than 55,000 databases, and the number is increasing every day. There's been a lot of feedback from the community members like yourself, so thank you. And this is a great, great day for us to make this feature generally available. And essentially, if you take a look at the target itself, Azure SQL Database, with this, we've truly focused on making the database part of it be completely easy for you. So as a developer, you can focus on the application without worrying about the manageability of the database. We collect about 750 to 800 terabytes of telemetry data that comes from close to 4.5 million active databases, like I spoke about in the beginning. And with that, we've been able to build a lot of machine learning models that enable us to help developers build highly performant apps. So we give you recommendations in terms of performance tuning, and for things like compliance and security. So GDPR and such regulations have become a pretty big deal these days in enterprises. And we've thought about it from the ground up in Azure SQL Database to make this available for you. So privacy and tasks, it's seamless and compatible. It's basically SQL Server running in the cloud with all the past benefits, beyond just the manageability pieces, like I said, performance tuning, security, etc., and at a very, very competitive TCO. We've obviously done a lot of market research everywhere, looked at every deployment option, and with a lot of confidence say that migrating your existing SQL Server applications to Azure is the best choice, both from a product growth and an economic standpoint. The best way to sort of understand the value of Azure SQL Database is through an exciting end-to-end demo. So let me invite Lara to show us all the cool stuff about Azure SQL DB.
Fantastic. Thank you. Thank you. And we are going to have some exciting demos. So first of all, Azure SQL Database is the most intelligent database service on the planet. It's highly available, it's secure, it's redundant, and you have the latest version of SQL Server that's available for you to deploy all in less than a minute. And that's fantastic. As a developer, I have a lot more time to focus on my application, a lot less time standing up and managing servers. Now, no other cloud gives us the security benefits that we get with Azure SQL Database. We've delivered over the last couple of years transparent data encryption, auditing, threat detection, and data masking. We recently also introduced the vulnerability assessment, which scans your database using a series of best practices and gives you recommendations on how to maintain a secure and compliant environment. But with compliancy requirements like GDPR, we know that scanning, masking, and encrypting isn't enough. You also need to know where you're storing sensitive data. With the data discovery and classification that we are just now introducing, we are using machine learning behind the scenes to recommend where you may be storing sensitive data. And not only that, but we're also recommending where the data may be sensitive for GDPR. You can take action right here in the portal and select the columns that you'd like to classify. And that's it. And this gives you two immediate benefits. The first, Azure automatically audits all columns that are classified. That means that your security admins and your monitoring systems can analyze the audit log, and that helps for compliance reporting and investigations. The other benefit is that we're storing the metadata around all data that's been classified. You can export reports that are based on this metadata for your compliance reporting. You can even access the metadata directly yourself if you want to build your own reports. Now, what's even more interesting is if you can access the metadata within your application, so you can change how your application responds based on the data sensitivity. So data discovery and classification is going to give you this holistic view of how your sensitive data is stored and managed across all of your data properties. This is going to be a big help for how you manage compliance. Now, in addition to security, we've also been innovating with performance. And right here in the portal, I have access to a full range of performance insights. I can find and drill into those top queries that are consuming resources because Azure is keeping a history of my database telemetry. In fact, Azure continuously monitors all the queries being executed, and it's using machine learning to make recommendations on how to improve performance in my database. I can take the recommendations that Azure provides, and I can take the script that it gives me, and I can apply this directly on the system myself. But what I think is even more interesting, right in the portal, I could choose to automate. Sorry, I'm going to move this down. I feel like it's... Is that better? I can choose to have Azure automate applying the updates for me. So Azure can auto-tune my database. That's unheard of. No other database anywhere in the cloud or on-prem does this. Now, don't worry too much, though, because if the performance regresses, if Azure notices a performance regression due to auto-tuning, it will regress, or it will roll back the changes that it applied and get it back to the last known good state. Now, many of you have applications that are running on SQL Server, and you want to migrate to Azure, take advantage of these features and many more. And with near 100% compatibility with on-prem SQL Server, migrating to Azure has minimal risk. And with the new database migration service, we also have minimized the friction. The database migration service can connect to any supported version of SQL Server from 2008 R2 on up. And it can also migrate from Oracle, Sybase, and what's coming soon with MySQL and Postgres. It supports two modes. There's a one-time mode, which is for simple migrations. And we've also now just introduced, as Rowan talked about, the continuous mode for mission-critical applications that require minimal downtime during the migration. But with the continuous mode, Azure's the database migration service will set up a continuous connection between your source and your destination and stream the updates to keep your migration up and running. To show you how this works, we have an application that's running right here. And as we scroll down, you can see that we're already connected right now to SQL Server 2008 R2. This is sitting in a virtual machine in my data center. And this could be sitting in any data center in any cloud. We're going to migrate our database to Azure. And to do this, we're going to use our database migration service. I've already set up my project, and my project is using the continuous mode that we talked about earlier. So when I set this up, the database migration service restored my databases into my Azure SQL database. It set up that continuous connection so I can continue to stream the updates into my Azure SQL database. And if we click in, you could see that the service is managing applying the updates in my destination, so I can continue to make updates on my source until I decide when I want to do my cutover. Now that my database is already up and running and everything is up to date, I can issue a cutover at any time, and my migration is complete. So let's go back to our application. Now that we've cut over to the cloud, I need to change my application. I've set up my connection string to my new Azure SQL database. And all I need to do is change my application setting to point to my new connection string. And let's restart IIS. Whoops. There we go. So in just a minute, you've seen how we were able to cut over our database. We've completed our migration. And I'm just changing my connection string. I made no other changes to my application. We'll refresh our application, and hopefully IIS is back up and running. Here we go. So there you go, with no other code changes. You can see that, there we go. Well, you can see down below, Zoom's not working. You can see that we're connected to Azure SQL database, and we're now in the cloud. So it's now in a cloud service, so it's highly available, it's redundant, it's got all of the great features I shared earlier, and many, many more. So I'm going to hand it back to Rowan.
Thank you, Laura. That was just awesome. You know, I'd love to show you a video of one of our enterprise customers who's really bet on the migration that Lara just showed, to tell you how customers like DocuSign are taking advantage of this new capability.
Hundreds of millions of people are DocuSign customers every day, transacting their most important business. For so many of our customers, their transactions are personal. We garner our customers' trust every day. Trust is the sort of thing that you earn in a lifetime and lose in an instant. We process 1.1 million transactions per day on our platform. Our transaction volume approximately doubles every year. What that means for me is that we are constantly scaling and evolving. We wanted the best of what we do in our data center, which is reliable SQL servers on flash storage, with the best of what Azure could bring to it, which is globally expanding, rapid deployment, high scale, with the best of what the SQL team could bring to it, which is a deep knowledge of the product and help in managing this thing at scale. And for us, we found that Azure SQL Database was the best way to do it. We deploy our SQL Server schema elements into a managed instance, and we point the application via connection string change directly over to the managed instance.
We basically picked up our existing build infrastructure and we're able to deploy to Azure within a few seconds. It allows us to scale the business very quickly with very minimal effort.
The holy grail in a move like this is being able to lift your existing platform, move it into Azure without significant amounts of work, without having to re-engineer things. And at the other side of that, get the incredible value that Azure brings to the table. Our hope is that Azure becomes the way we do global expansion. We want to help customers all over the world bring their paper processes into the digital world, to allow us to be the accelerant that they need to move faster and faster into this digital transformation.
You know, that is a great example. You saw Eric in the video, who's the CTO of DocuSign, say, they're very happy with their application, what they've built on SQL Server, the way they run it on-prem. They fine-tuned it. It works fantastic on the the hardware that they have. They'd really bet on Azure for global expansion. They were not really looking into changing a lot of their application. For them, a good win is really when they take their exact setup that they have, use something like the database migration service to do the mission critical migration of their app, and all of a sudden they have their presence in every data center that Azure's in every region that Azure is available. So turnkey global expansion, which is fantastic from their business standpoint, right? So this is a great example of how we're sort of taking our innovations, getting them together to solve what we're hearing from our customers. So that's really great. While SQL Server and Azure SQL database migration service, these investments are for us. SQL Server is really the heart and soul of what we've done for several years, and that'll continue to be. One of the things from an Azure standpoint, what you've seen is there are several of our customers who've bet on open source databases like MySQL, PostgreSQL, and MariaDB, right? And this is we've been speaking about this for a very long time now, that Azure is first and foremost a very, very open platform. So if a customer of ours has already made the decision, for whatever reason, a lot of times it's really based on the app frameworks, that they pick, or there's a lot of new development that we see happen on Postgres databases, especially in the open source community. For us, it's really about meeting the customers where they are. We're not going to have a discussion about somebody who's chosen that database to go and try to convince them to move to SQL. That's really the wrong conversation as far as we are concerned. So one of the things that we've done, and which we're super proud of, is recently we've made services for MySQL and PostgreSQL on Azure generally available. A few weeks ago, we made that announcement. And foundationally, these services are built on the same PaaS fabric that created and added value to SQL Server. So effectively, we leveraged a lot of the learnings of making SQL Server into a PaaS database. Going in, we had certain principles. We wanted to stick to the community editions of these open source databases. Right? So the core engine that we use for Postgres, MySQL, MariaDB is exactly the engine that's shipped by the community. So we don't make any changes in terms of the app surface area and such. So for us, what that means is while you get the benefits of PaaS, all the existing ecosystem in terms of tools, languages, ORMs, etc., just work outside the box. So whether you use Java, Node, PHP, etc., with MySQL or Postgres, they just work outside the box. Since it's built on the Azure fabric, you get elastic scale up and down with close to zero downtime. Right? This is exactly the feature set that we've added to other Azure data services. Since it's built on the same fabric, you get that with MySQL and Postgres as well. And this is something that we've heard from our customers who bet on these databases about something really, really valuable to them at a price point that makes a lot of sense. It's secure and compliant. This is just the core foundation of Azure. So encryption at rest, secured connections to connecting to these databases by default is something that's just built in. So all the investments that we've done around security, compliance, GDPR, etc., all accrue to these data services as well. We get the global reach of Azure. So if you want to basically create a Postgres or MySQL or MariaDB managed services, MariaDB is still in private preview. The other two are generally available. You can basically go to any one of the Azure data centers. So today, we are in 20 to 25 regions and growing rapidly. Very quickly we'll be there in every region that Azure supports. So you can basically have an app that's sort of distributed in any of these regions. And finally, and this is one of the things that's very uniquely differentiated for these services in Azure, is that we've taken a lot of pain to integrate them with other data services. So things like Power BI, cognitive services, Azure Machine Learning, Bing APIs to do intelligent ML or AI kind of applications on top of the data that's stored in these databases. We've taken a lot of pains to make sure that these experiences work end to end. One of the ways to basically see the value of what we've built is through a real customer case. And so let me play a video.
We live in a society where engineers and developers, coders, are really at the forefront of societal change.
So we ended up starting GeekWire. Startups are really at the heart of what GeekWire is about.
The website is our lifeblood. Reliability of the site is critical. It's not unusual for the site to experience a 5x, 10x increase in traffic. We migrated the site to Azure, and we host the site on a variety of different Azure services to support those really unpredictable traffic spikes. GeekWire runs on WordPress. We needed the ability to run a web server farm running Nginx and PHP. We needed a CDN where we can distribute our image assets, a Redis cache to help cache and manage the traffic spikes. Microsoft Azure offered all of those services. The decision maker was when Microsoft launched a new version of a managed MySQL instance, so we could also run the database layer together with that whole stack. We're also using the Azure App Service, which gives us the ability to automatically scale our web server.
One of the first tests of our new Azure implementation came with some breaking news. SpaceX just took off, and Azure just scaled right up with it.
We have a much more powerful infrastructure that can support a lot more traffic at a lower cost.
We love that we've built this business here at GeekWire in a scrappy, bootstrapped style, and that Microsoft has developed an ecosystem around the startup community.
That's a great example. Like, who would have thought GeekWire, which, you heard in the video, startup bet on open source, is fully built on Azure, and they're leveraging the open source database services that we've shipped. And this is truly an example of how Azure is such an open platform. There's an example of new Microsoft that Satya's been talking about. Well, the best way to, again, look at what we've done in terms of these open source services, especially on Postgres, is through a demo. So let me invite Rachel.
Thanks,
Can you show us
Sure.
all the cool stuff that we've built? Thank you.
So as Rohan and Lara mentioned, we're excited to see you guys move and migrate your existing PostgreSQL and MySQL database workloads to Azure. We're also looking forward to the growing wave of cloud-native applications. These are applications that are born in the cloud from day one. So let's imagine that I'm a developer for a public library system here in Seattle, and I've been commissioned to create a web app for them. Azure's rich ecosystem of services enables me to develop all these scenarios. So let's say I'm interested in using Kubernetes. I've created a cluster using Azure's managed service for Kubernetes. And the cool thing is that directly from this cluster, I can provision Azure Database for MySQL and Azure Database for PostgreSQL servers, and then bind them to the cluster. So let's go through that. I select PostgreSQL, pick the general purpose tier, give a name to my service instance. Here, I can specify even more parameters, click Submit, and that server is going to be provisioned asynchronously and bound to my cluster. So I've already created servers for that, and they're acting as the back end for my web application, which is here. So this is showing what demand looks like for the various books in our inventory. Now let's talk about scale. Seattle is a really fast-growing city. In fact, about 60 people move here every single day. So we can expect that the user base of our library is going to grow. We're also going to add more inventory, and generally the database and data is going to be multiplying. With Azure Database for PostgreSQL and MySQL, scaling up that storage is just a short command away that I can do through the Azure CLI. I could also alternatively do it from right here from the portal. So as you can see, I can scale compute and storage independently of each other so that I can have exactly the amount of resources that I need. So summer, for example, is a pretty peak period for libraries, and we want to scale up our compute so that we can match the higher number of concurrent users that will be connecting. And once summer is over and that peak period is down, well, I can scale compute right back down to match it. Azure Database is also managing backups and patching for me, and overall, it gives me more time to bring additional value to my application. For instance, during our app user testing, we saw that when users are in the app, they want to get a little bit more information about an author before they make a decision. But if they decide to exit to another window, well, they kind of drop off and don't return to the app. I can address that by integrating our app with Microsoft's Cognitive Services, which is a suite of APIs that are unique to Microsoft. Specifically, I will be using the Bing Web Search API, which I've integrated into the app. Let me show you that in Visual Studio Code. So here, I'm calling the Cognitive Services API, and I'm getting web results as a JSON, which I will then display into the app. So returning to the app, if a user clicks on one of the authors, they immediately are able to see search results displayed and embedded right into the app. Another thing I've got to do with more of my free time is make use of some of the data in our database that has been previously underutilized. So when our users give us permission, we're tracking location data, that is where they are when they're connecting to the app. Using Power BI's connector for Postgres, and the Esri chart, I'm displaying that location data as a heat map that immediately makes sense to our business planners. That purple shaded section shows the areas of the city that are within a 5-minute drive from our branch location. So immediately looking at this, our business planners are able to make more informed decisions about where to open our next branch. These are just a couple examples of the innovations that Azure and Azure Database for PostgreSQL and MySQL are enabling developers like you to do so that you can do more of what you love. And we invite you to discover these services for yourselves. Thanks.
Thank you, Rachel. So you basically saw how the investments we are making in the hybrid pillar of our data platform strategy, across SQL Server, the migration service, MySQL and Postgres databases, On-prem investments in SQL Server, that's a pretty important part in which we'll continue to do, and you'll hear more about that in the subsequent months. And by the way, the database migration service, like Rachel mentioned, it's not just, obviously we've made it really, really simple to migrate your existing SQL Server applications to Azure SQL Database, but you can use that to migrate Oracle apps, you can use that to migrate Sybase apps, you can use that to migrate MySQL apps to the MySQL service, Postgres apps to the Postgres service, and we're going to keep adding more and more source and destinations. So a lot of these are available in private preview today, so if you'd basically like to try them out, please send us an email and we'll sign you up for it. So the next pillar that I want to talk about is around intelligence. This is where when you take a look at a lot of the new globally distributed applications that weren't possible before, that are getting built in the hyperscale public clouds right now, are enabling where the volume of data that essentially that's getting produced is so significant that you have to think about getting the intelligence. When you talk about operationalizing or training your machine learning models, and then enabling them for scoring, it has to be where the data lives. So in some sense, the AI and the data platforms have to go hand in hand, and this is something that we've thought from the ground up. So for us, when we think about intelligence, it's really, really a core part of the data platform itself. Let's talk about Azure Cosmos DB. So Azure Cosmos DB is our globally distributed multi-model database that exists in Azure. We very strongly believe that there's almost nothing like it anywhere else in the world in any of the other clouds. It was foundationally built over 3 core technical principles around partitioning, replication, and resource governance. So partitioning essentially enables a database in Cosmos DB to essentially scale infinitely. Effectively, you can horizontally scale the storage and the throughput as much as you want, like all the way up to millions and millions of transactions per second. Right? So that's really what the partitioning, that's core, that's built into the database platform, enables you. The other core piece of technology that we built at the foundation of Cosmos DB is replication. That enables us to essentially support turnkey global distribution of data. So with a few clicks, like you might have seen in several demos, you're able to replicate data in all the Azure regions of the world. In fact, we have customers today who are basically replicating data in all the Azure regions. A single database is being replicated across all the Azure regions. And finally, resource governance. This is fine-tuned governance that we do at every node that essentially enables all the comprehensive SLAs. There are a lot of services in the industry that support SLAs for availability. Cosmos DB supports 5 nines of availability. But it's the only data service that's there in the world that supports comprehensive SLAs which are financially backed for both latency and throughput. We are so confident in the core architecture that we've built that we see this, even though we say up to 10 milliseconds, in practice what we see is something which is much, much less than that, between 1 or 2 milliseconds. We're excited to announce, you must have heard in Scott's keynote this morning, support for multi-master. So instead of just reads being everywhere in the world where you could go into every region, now you can essentially update your database from various regions in Azure. So you get much higher write availability, much higher throughput for writes, and low latency depending on wherever you are. And support for VNets, again going back to the discussion we had around just strong foundation for security and compliance is something just for all our data services that we have in Azure, and Cosmos DB is no exception. The best way to basically look at what we've done with Cosmos DB is through a demo. So let me actually invite Lewis to show us all the cool value that we've added with Cosmos DB. Thank you, Lewis.
Thanks. Hello. All right. Thanks, Rohan. So as you probably know, Cosmos DB has a graph database engine called the Gremlin API. The Gremlin API is Apache Tinkerpub's standard. It's based on Apache Tinkerpub's graph database standard that is an open source set of frameworks that define functionality in graph databases. And Cosmos DB is the only graph database that's a fully managed database service in the market in general availability today. So in this demo, this is going to be a little bit different. We'll use this graph technology to design and work around some of today's most dreaded problems. Navigating airports. So let me know if this problem sounds familiar to you. Your origin flight is delayed, and you land at your layover for much later than expected. And what used to be like an easy stroll through an airport now becomes this really complex, most optimal path that you have to go through to avoid crowds, stop for food, go to security, and then have to go to your destination gate. How many people relate to that here? Since you flew all the way to Seattle from wherever, so We're going to solve this problem today. And for that, we have to choose one of the airports that's representative of crowds, delays, and varying degrees of food quality. I'm, of course, talking about LAX. So we'll start with the data modeling for this exercise, since you know that data modeling is actually half the battle in many of today's data problems. So this is a map of LAX, and we're going to use graph objects known as vertices to represent each of the terminals. Now, each of the terminals are connected with graph objects known as edges. Edges, in this case, represent paths between terminals, and we're going to use them also to store the time it takes to travel between them. Now, inside of a terminal, we're going to do the same thing and represent each of the gates with a vertex, as well as edges to represent each of the paths between the terminal and each of the gates, as well as the restaurants. What is not shown here, and it's shown in this diagram, is how each of the restaurants is connected to each of the gates back and forth to support the largest number of scenarios possible. So let's look at how this data is implemented in the Azure portal. So for this, I created an Azure Cosmos DB Gremlin API database. And since this is a problem that can be experienced in any part in the world, since you can fly from anywhere to LAX, which is a big international hub, we have decided to replicate this data using Cosmos DB built-in turnkey global distribution. So in this case, we're using, with a single click, automatically replicating the data set to each one of these Azure data centers, which, by the way, Azure is the cloud platform that has the largest number of regions and data centers in the world. Now let's look at the data. In this view, this is actually the data explorer for Azure Cosmos DB. In this view, you can see how each of the terminals is connected and how you can navigate through them. Also remember that we're storing each of the paths and the distance between them in the edges. Now, how many restaurant options are in LAX? Well, we can use this query, and then we can see the list of all of the restaurants and non-trademark names of restaurants that we have to come up with in each of the terminals in this data structure for an airport. Now, this query will show us the internal of a terminal. And in this terminal, you'll see all of the gates and all the paths stored between them. Each of the paths is stored as a document in the backend of the database. Now, to solve the problem, we're going to use this verbose Gremlin query. And what this query is doing is basically lands at a gate. First of all, it searches for a gate. Then it lands at a gate, and it explores two paths. All the paths between this gate and the restaurants in this terminal, as well as the destination gate, and all the paths between this gate, the restaurants in the other terminal, and the destination gate by switching terminals, as well as discarding all the paths that are recursive or can end up in infinite loops. So I'll just probably go make myself a coffee with this query runs. Just kidding. It took like a second. Actually, less than a second. So with a single query, we are able to calculate all of the optimal paths. Thank you. Calculate all of the optimal paths, and then filter this data set, as well as obtaining all of the solutions in a matter of milliseconds. So what I'm going to do next is I built an application that actually visualizes this information in one of the most useful ways to visualize this as a Gantt chart. So here, we're scoping all the solutions to the ones that are 50 minutes in length. And in each of the segments represents all the time that it takes to go through one of the options. But this is not enough. As you know, airports are very volatile, so we don't really know how much traffic there's going to be, unless we use Azure Databricks. So here in this notebook, I am pulling a data set for LAX passenger traffic from Cosmos DB in a large partition collection. We are using Cosmos DB's Spark connector for this. And we're passing in a custom SQL query that will then give us different insights, like this one, for example. Here we see that Terminal 1 experiences the highest traffic with 340,000-ish passengers per month. And, for example, Terminal 2 is one of the lowest passenger traffic terminals with 125,000 visitors per month. So what we're going to do here is going to pass this to a machine learning classification algorithm that's going to draw these conclusions automatically and then send them to the second version of our application. This version of our application, the application will know that, excuse me, the application will know that Terminal 1 is one of the highest, one of the terminals with the highest traffic, and it's going to be able to know to discard the options of restaurants that are in Terminal 1. So what's happening here is that this piece of logic no longer has to reside in the application, but it can be delegated to a database that can actually run through the most optimal way of querying these results. So this is just an example of how you can use the power of Cosmos DB Gremlin API, as well as Spark-enabled analytics in Databricks to create innovative solutions at a global scale. That's it. Thank you.
So thank you, Louis. We have several of our large customers who were making a huge bet on Cosmos DB. And one of the customers who's been with us on this journey since the beginning is Jet.com. So let me invite Scott, who's the Director of Engineering of Jet.com, for a conversation. Hey, Scott, thank you so much.
Thank you, Brian.
For coming. So can you share a little bit about your business and what do you guys do?
Sure. Jet.com is a mass market e-commerce company based in Hoboken, New Jersey. Right out of the gate, we had to deal with massive scale and massive growth. On our very first day open in 2015, we had revenue of over $1 million. A year later, we were purchased by Walmart for $3.3 billion. We now compete with Amazon as part of Walmart. Our product catalog has 31 million SKUs. If you want to buy it, we probably have it.
Wow, that's impressive. I'm sure it's huge scale too. So tell me, what kind of business problems were you facing, and how did technical solutions, what kind of solutions you looked at, and how did Cosmos DB help?
Well, first of all, data at Jet.com and at Walmart means scale. E-commerce is going to be $1 trillion business over the next 5 years. We need a database that will grow with us, and that's why Azure Cosmos DB is such a critical part of our vision. Not only does it need to scale, it needs to elastically scale up and down on demand so that we can control our costs. On our busiest shopping days, we can deal with 20 times as many events as on a normal day. On Black Friday last year, we provisioned throughput for 1 trillion requests in a single day by provisioning a geo-replicated Cosmos DB collection with 10 million request units per second.
Wow.
And yeah. Another key aspect is that we need to move fast so we can keep ahead in a competitive environment. Our teams have settled on a functional first development methodology that relies on microservices and event sourcing. Event sourcing lets us not just store the application's current state, but the history of the state by saving all of the changes as a sequence of events. And the Azure Cosmos DB change feed can then publish those events without the problems that you usually get with dual writes.
That's awesome to hear. So can you share a little bit about one of your microservices and the architecture in a little bit more detail?
Sure. Let's talk about the next generation inventory management system we call Panther. For tracking inventory, we track all of the available SKUs at all of the warehouses or all of the merchants with whom we interact worldwide. The business goal here is to make sure that we minimize our reject rates from lack of inventory. So there were several business goals that we had when developing Panther. One, we wanted to improve the customer experience by moving the reservation of items earlier in the order pipeline. Two, we wanted to enable our order management teams, operations teams, and marketing teams with more history and better analytics over that historical data. And third, we wanted to unify the inventory management responsibilities that are traditionally spread over multiple teams. So to implement this in Panther, when an item needs to be reserved, we have a microservice receive a reserve inventory command. The service then retrieves the item state from Cosmos DB, executes the command against that state, which produces an item reserved event. That event then gets committed back into the item's event stream in Cosmos DB. Now, we see in practice that the reads and writes are both single-digit millisecond latencies, which is absolutely critical for keeping up in our business. And then the Azure Cosmos DB change feed then transmits these events to any of the consumers worldwide. If you want to hear any more about this, I've got a breakout session at 4:30 in the Sheraton Grand Ballroom A. Thank you very much, Ray.
Thank you so much, Scott. But there you go. How the amazing part and scale of Cosmos DB is helping Jet.com. And if you have want to learn any further, there's I'm sure several sessions that we have for all our data services. So please check them out. And moving forward, on the analytics side, you sort of spoke about how a store like Cosmos DB allows you to sort of ingest data at very high scale and distribute the data globally, serve data with millisecond latencies guaranteed and are financially backed. But one of the patterns that we are enabling in Azure is this whole notion of a modern data warehouse. And when you think about the modern data warehouse, you have to really think about three things that have to work together. And what you see on the slide is a service for each of these that we have built. The first one, in any sort of data integration or data warehousing solution that you build, is the integration pipeline. Everybody talks about AI and analytics and everything when the data lands up in the right place, but 90% of the time, if you speak to the data engineers, gets spent in really building those connections, building those data integration pieces together in a way that the data lands up in the right place, right? And so we're very excited to announce that in the next couple of months, we're going to be making our Azure Data Factory, version 2, the new one that we released recently in public preview, generally available. We've heard amazing feedback from our customers. It's extremely flexible. It supports, connectors to more than 60 sources and targets. And, that set keeps growing, with every month, every semester, we add more and more connectors based on customer feedback. And effectively, we are able to build very, very reliable pipelines using the orchestration mechanism that we have with Azure Data Factory. Now, the second piece of the puzzle, so you sort of set up the pipelines, you landed your data in Azure Storage, is around preparing the data, right? So you have lots of unstructured data, semi-structured data. If you think about various systems, CRM, ERP, if you have IoT applications which are sending sensor data, you have to get the data into the lake and then prepare it in a way that sort of becomes meaningful for serving. And we basically have the best Spark in the industry with Azure Databricks. We've partnered deeply with the company Databricks, where the employees actually were the ones who created Spark, right? And they basically have built this amazing experience around notebooks, which you're going to see here in a second shortly, that essentially allows you, as data engineers or data scientists, to basically prepare the data, train the models in a way that's extremely intuitive and seamless. Now, once the data is prepared, now you need to sort of put it in an enterprise data warehouse to serve it. This is where all your BI, analytics, et cetera, come to bear. And that's really what you get with SQL Data Warehouse, which is the third pillar of the story. And we're very, very excited that very recently we released the general availability of the Gen 2 architecture, which leverages adaptive caching. So we basically have redesigned from the ground up the hardware SKU, where we're leveraging NVMe SSDs locally. So we cache a lot of data from the remote storage based on statistics on pages and such, which allows us to serve the queries in a very efficient manner. We've seen up to 100x gains in queries while maintaining the elastic architecture, by the way. So all the benefits that you had with the Gen 1 of Azure SQL Data Warehouse, where you could pause an instance when you didn't need the compute power, or whether you could scale up and scale down, very, very simply. So all those benefits, which are very, very unique to Azure SQL Data Warehouse, we maintain them. Now with the adaptive caching that we built into the data warehouse, the queries are just blazingly fast. So you put the latest version of ADF with Azure Databricks, which is the industry-leading Spark that we have in Azure, plus all the advancements that we've done with Azure SQL Data Warehouse, you have a fantastic end-to-end system that does modern data warehousing for you. And of course, it's very well integrated with other services when it comes to Active Directory for security, keeping data at rest encrypted, working with Power BI, and a huge slew of other tools that we support. Now, again, just like we discussed in the previous section with Cosmos DB, let me invite Adrian, who's the chief engineer of Rubrik Cloud, who's been on this journey with us with the analytics pipeline that we had for a very long time now. So, hey, welcome, Adrian.
Thank you, Rohan.
How are you doing?
I'm great.
Good.
How are you?
Good. So, can you share a little bit about Rubrik Cloud and your business and what do you guys do?
Yeah, absolutely. So, Rubrik Cloud is a Canadian startup based in Toronto. And our core thesis has always been that artificial intelligence and machine learning, it is a really transformative technology, but it can only really apply to enterprise use cases if you take a really narrow and vertically focused approach, right? And if you have deep domain expertise baked into the very fabric of your company. And for us, that fabric happens to be intelligent decision automation for the retail industry. Specifically, really large enterprise retailers with both online and brick and mortar presences, the kind with really compelling data problems that come from a long legacy of migrations and acquisitions and so forth.
Perfect.
Yeah. So this thesis has manifested itself into two sort of flagship products. The first we call Promotion Manager, and this one focuses on setting price, inventory, and mass promotional mechanics like flyers. And the other one is called Customer Lifecycle Manager. And this one focuses on environments where there already exists a really high penetration loyalty program, which we can use to tailor specific promotional mechanics for each individual customer based on their specific behavioral history. So these two flagship products, plus a suite of sort of expert services and data platforming tools, form the backbone of our offering right now.
So clearly, analytics is all over what you guys do. So can you share a little bit about how betting on the Azure Analytics stack has helped you innovate faster?
Yeah, absolutely. So no matter what anyone says, the real first step of any ML pipeline is actually just plain old-fashioned ETL, right? Even if you're only talking about a single business unit at a single retailer, that likely still comprises literally dozens of disparate data sources like CRM and point of sale and marketing automation tools, each with their own completely different data schema, most of which aren't even on the cloud yet, right? We have to be that cloud. We have to be their data warehouse. And that's where our partnership with Microsoft Azure really comes in. See, we've built a declarative ETL pipeline that can take almost any conceivable retail data source and convert it to a single canonical data model that all of our downstream processes can understand regardless of client. And this pipeline runs on Apache Spark on either Azure HD Insight or Databricks. Now, each stage of this pipeline is going to read its data from and write its data to Azure Storage, thanks to the really truly seamless integration between HDFS and Blob. And then finally, Azure Tables act as a kind of message bus, passing dependency information and state between all the kind of moving parts of this concurrent distributed system.
Cool, thank you. Data warehousing is typically associated with BI and analytics, but based on what you're describing, you guys do a lot more than that. Can you explain a little more as to how you use warehousing?
Right. Well, the truth is, if the only consumer of all of this data was our own products and services, which are largely just Spark jobs anyway, then having all this data just be represented as Parquet files sitting on Blob somewhere, that would be totally fine. And in fact, most of our products and services do in fact use Azure Storage as their default write output. But the reality is that business users who also need this data for analytics and performance and monitoring and that sort of thing, realistically, they're just not going to be spinning up a Jupyter notebook or opening up a PySpark shell and running custom data frame transformations, right? That's not going to happen. So then the model of Azure SQL Data Warehouse of separating the compute and the storage is really just a home run, a perfect fit for this use case, right? They get to continue using all of the familiar SQL-based tooling thanks to the ODBC connection built into SQL DW. They get free data security and authorization thanks to the integration with Azure Active Directory. And they get to continue using what's probably the most well-known and widely deployed SQL dialect in T-SQL. Right? So this is already a huge win. Just the fact, the ability to spin up compute on top of data that we would have kept in an Azure Data Lake storage anyway, that's already a win. But then the ability to also bring in external tables through Polybase to layer on data that comes from downstream ML, that's really powerful, right? It's what allows us to bridge the gap between the traditional BI world and the kind of black box of machine learning. We're giving them access to model outputs and network weights that in a more traditional architecture would be stuck in some operational database somewhere, right? Those don't traditionally end up in a data warehouse at all. So this is kind of the game changer. And then finally, retail is obviously a very seasonal and very peaky business. So price and promo, that's always happening. But the demand for BI, while it's always high, it's never constant. Neither on the macro scale, right? You can think of the holiday season or Black Friday, but actually not even on the micro scale. We often see these huge peaks of traffic on the Monday evening right before the general meeting on Tuesday morning. So the fact that SQL DW can actually just go from sort of manageable performance at a couple hundred DWUs to really breakneck throughput at 18,000 DWUs, or actually now up to 30,000 DWUs yes. with Gen 2. Congrats on that. And the fact that it can do all of that really on a dime without us having to actively redistribute or repartition data, at least not on the layer that we're operating on. That's what allows us to keep our costs down and then therefore pass those savings on to the client. And this is something that really is unique to Azure, right? Scaling something like AWS Redshift up and down, you can do it, but it takes ages. And then even once you've done it, the compute and storage layers are inextricably linked. You can't really have more than a couple of terabytes on Redshift without paying for literally dozens of compute nodes, expensive compute nodes, that you may or may not actually need depending on your compute latency requirements. So for us, this is another huge win for Camp Microsoft.
Cool. Well, thank you so much, Adrian. Really
Thank you,
appreciate
Rohan.
your help. Thank you. All right, so I think we've sort of spoken all about how the services come together. Let's bring it together, Nishant, by an amazing demo.
Sure thing. Thanks, Rohan. Hi, everyone. Today, I'm going to show you how a smart retailer is leveraging analytics and AI to transform one of the most important metrics of their revenue, product sales, which is very heavily influenced by product discoverability. Let's quickly dive into the demo over here. Here I'm on the Azure portal where I can access all my analytics services for all my requirements and even go ahead and create new ones like the recently announced GA for Gen 2 of the data warehouse. Now, the data warehouse is a very typical concept. It takes you weeks, if not months of effort to go ahead and set up and tune properly for your business. But with Azure, you can set up a data warehouse just with the help of a few simple clicks. And what's more, you even get to define what is more important for your analytics workloads because you get to choose the performance levels right here. Now, as I go ahead and choose the performance levels and I go to Gen 2, I can scale up my data warehouse to thousands of cores. Imagine the amount of power your complex queries running against massive amounts of data are going to have with these many cores working in the back end. But now the data warehouse is great for my structured data and a lot of semi-structured data as well. But what if I want to extend it to deal with unstructured data in a more sophisticated manner? Well, that's where Azure Databricks comes in to complement my data warehouse very seamlessly. Let me quickly take you to an Azure Databricks workspace. Now, Azure Databricks is the fastest, easiest, and the most collaborative Apache Spark-based analytics platform on Azure. And a workspace with Databricks hosts all of my Databricks assets. It hosts my clusters, my jobs, and most importantly, my notebooks. Let me quickly go and start executing one of these notebooks to see some code in them. And as I execute them, let's understand what these notebooks are. Now, these notebooks are a relatively new but a very novel concept for data engineers and data scientists. These are like playgrounds for all of your analytics. You can execute command, visualize results, again, against massive amount of compute. And all of this in an auto-scaling serverless fashion. Now, with Azure Databricks, we take it a step further by adding collaboration, scheduling, and version control to it as well, so that you can stream it right into your CI/CD pipelines as well. Now, since we're talking about retail over here, what I want to tap into is determine what my product discoverability looks like. So the first data source that I tap into is the treasure of rich historical sales and product information that's already contained in my data warehouse. Now, with Azure Databricks, I can leverage a native built-in connector that Microsoft has built in conjunction with Databricks to extrapolate all the parallelization that you can leverage from the humongous number of cores that you have at your disposal. And all of this with such simple connectivity as we see over here. We can visualize the results, query them, slice and dice them, whatever. Now, the second data source that I need is the clickstream data that contains user patterns within my apps and websites. Now, this is all unstructured data, as I see over here. How do I make sense of this? This has a lot of rich potential because of user behavior patterns. Now, with the Spark engine that powers Azure Databricks, I can quickly and easily parse through this data as well and convert it into a much more structured format. What this allows me to do is now combine my structured data and my unstructured data to derive combined insights. A perfect example of that is this product lifecycle graph that I have over here, where I've plugged in user behavior patterns against product lifecycle from the perspective of sales. Now, as I look at this graph, it is clearly visible to me that my products are only visible towards the fag end when they're on clearance or heavily discounted. I'd love for them to have a much better potential towards the early or the middle phases of the cycle. This leads me to believe there's a problem with my recommendation engine. They're not placing the right products in front of the right customers at the right time. Let's go ahead and see what's happening over here. As I see, I'm leveraging a pretty sophisticated clustering algorithm called LSH. Again, within the same environment, wearing a data scientist hat with the same platform, same tools, and the same languages inside of the notebook. Now, I'm just going to go ahead and pull up the recommendations, and I'm going to pull up the images as well so that you get to see what our users see on their apps and websites. So for this test image of women's sandals, I'm getting recommendations for men's open toes and sandals. Now, this is certainly not ideal. You need to show recommendations based on what users are seeing, not for the opposite gender, right? So I wonder if I could just leverage these images to infuse even more intelligence into my machine learning model. Well, why not? With Azure Databricks, I can actually go ahead and do that. I'm using a deep image featureizer, which is part of a sophisticated AI toolkit called TensorFlow, and I'm extracting features from these images to add more contextual information to my models. And as a result of it, now my models are showing much better recommendations coming off it. Now my next step is, of course, to deliver these to my users. Where do I go? Well, I don't have to do anything. I can deploy these recommendations right from my notebooks into an operational store like Cosmos DB that powers my end user apps and websites. Just to see how these recommendations are doing now, I'm going to pull up a real-time dashboard that's consuming my user behavior patterns in real time via Kafka streams into this particular dashboard. And as I see, I've just deployed it to the US, and it's showing much more positive responses from my users. As the global distribution of Azure Cosmos DB takes effect, these new recommendations are going to flow into the other regions and show me much more business coming in from there. Now, that's not all. Now that I've enriched this data, I can also feed it back into my data warehouse for my business users to start consuming it. But some of you must be wondering, am I going to have a data engineer or a data scientist sitting in front of these notebooks while I deploy this entire pipeline? Well, not really. As Rohan mentioned earlier, we've got Azure Data Factory. Now here's an Azure Data Factory pipeline that has operationalized our end-to-end pipeline in a very seamless manner. I can tap into data sources, whether they are on-prem or in the cloud. I'm leveraging the same Databricks notebooks in the form of tasks over here and feeding it back into the data warehouse. As a developer, I can even set breakpoints and debug my pipeline in entirety or in parts. And I can even come back and monitor runs that have happened over the last few hours or few days, etc. So I can just come in over here, select the runs, look through them, potentially even debug them over here. Now the last part, now that I have all these insights in the data warehouse, deliver them to my business users. Exactly what I'm doing over here. My Power BI connecting to the data warehouse to suffice complex queries from hundreds of concurrent users at the same time. Just to recap, in a few minutes, we were able to combine structured and unstructured data. We were able to collaboratively create an AI-infused machine learning model on this data, and then we were able to create a real-time feedback loop from customer behavior patterns. This is the power of an integrated analytics platform. And with Azure Databricks, SQL Data Warehouse, Cosmos DB, and Data Factory, we have the ultimate big data analytics platform for our customers. I hope you enjoyed the demo and are as excited about the platform as we are. Over to Rohan.
So thank you, Nishant. And well, that was quite a journey in an hour and 15 minutes to sort of take you through the entire data platform. I mean, there's lots of deep dive sessions that are there for all our services. Please take advantage of them. And last but not the least, do complete your evaluations. We'd love to learn from you as to how we can improve these sessions for you as we move forward. I'll leave you with one thought. For us, like I mentioned, data volumes, AI, and the cloud coming together is fairly transformational. Just think about what that means for your industries, for your companies, and for your customers. And we really, really want to partner with you to make this an amazing transformation for all of us, to create breakthrough experiences and change the world. Thank you so much.